Have you ever just stopped and wondered how someone's brain can handle more than one language without, getting all tangled up? Well, in this explainer, we are diving headfirst into a really cool new study that uses virtual reality to get us closer to an answer than we've ever been before.
So here's the central mystery, right? The big question that has fascinated cognitive scientists for decades. How does our brain juggle multiple language systems? How does it keep them separate but ready to go at a moment's notice? It's this incredibly complex cognitive dance, and honestly, we're just beginning to understand the steps.
And our insights today are coming from a really groundbreaking 2024 paper from the Journal of Cognition. It's called Multilingualism at the Market, and it's by Titus and Peeters. And believe me, they used a completely new approach to tackle that very question.
So here's how we're going to break it down. First, we'll look at the core challenge inside a bilingual brain. Then, we'll check out the traditional lab tests, and after that, we'll get into the two new experiments, one on a computer and the other inside a virtual market. And finally, we'll unpack what they found and what it all means. It's going to be great.
Okay, first things first. Let's get a handle on what's actually going on inside a bilingual person's mind, like every single day.
The most important thing to get is that for a bilingual person, neither language ever really shuts off. All the evidence shows that both languages are active in the brain at the same time. This creates this constant, subconscious competition, kind of like a mental tug-of-war, that requires an incredible amount of control to manage.
So, if this constant internal battle is happening, how have scientists usually tried to study it? Well, let's take a look at the classic lab setup.
For years and years, the go-to method has been a computer task called the cued language switching paradigm. It's actually pretty simple. You, the bilingual participant, see a picture of, say, an apple. Then you see a totally random cue, like a blue square, that tells you which language to use. Then you just name it, and scientists measure how fast and accurate you are. That's it.
And this simple little task revealed something huge. It's called a switch cost. This is that tiny, measurable delay, we're talking milliseconds, that it takes the brain to jump from one language to another, compared to just stay in the same one. It's thought to be a sign of what's called reactive control, the brain hitting the brakes on one language and hitting the gas in another right in that instant.
But these tests also uncovered something totally weird, something you wouldn't expect at all: reversed language dominance. In these experiments where you're mixing languages, bilinguals are often faster in their weaker second language than in their own native tongue. How crazy is that?
So why on earth would that happen? Well, the main theory is that it points to a whole different kind of control, something called proactive control. To make things fair, it seems like the brain puts a constant, gentle brake on the stronger dominant language for the entire experiment. This kind of constant suppression makes it way easier for the weaker language to pop out when it needs to.
And this brings us right to the big, looming question that really kicked off this whole new study. How much does naming pictures on a screen based on a color really tell us about talking to actual people? Does the real-world context of a conversation completely change the game?
To figure that out, the researchers first ran a baseline experiment. They basically took the classic test and just added a little twist to see if those old results would still hold up.
The setup was almost exactly the same. A computer screen, those artificial color cues, but with one really important difference. Instead of just saying a single word, the Dutch-English bilinguals had to say a full sentence, something like, "The potato costs 30 cents.
And what did they find? Well, this chart says it all. The results were a perfect mirror of the old studies. They found those symmetrical switch costs. It took about the same amount of extra time to switch into either language. And, yep, they still saw that weird reverse language dominance thing happening. So, making them say full sentences didn't change a thing.
Okay, so with that baseline set, the researchers moved on to experiment number 2. And this is where it gets really, really cool. They decided to take the whole test out of the lab and into the real world. Sort of.
They completely ditched the computer screen and put people inside an immersive virtual reality marketplace. The participant got to be a fruit stand owner, and the cues weren't colors anymore. They were life-size virtual customers who only spoke either Dutch or English. All of a sudden saying the eggplant cost 50 cents wasn't just a task, it was real communication.
And this is the part that'll blow your mind. The second that the context became more realistic, more social, the way the bilingual brain managed its languages totally changed. The results were completely different from anything they'd seen before.
Just look at this. In the VR market, the switch cost to go back to their dominant language, Dutch, just vanished. It's gone. In fact, it's a negative number, which basically means it was completely effortless. But, and this is so important, the cost to switch into their second language, English, was still there. That perfect symmetry they saw before, totally gone.
This table just lays it out so clearly. All the past studies and their own baseline computer experiment both showed symmetrical switch costs, a little time penalty for switching into either language, but the second you put them in that realistic VR market, that pattern just shatters. We get a brand new asymmetrical result.
Okay, so what does this huge shift actually tell us about how the bilingual brain works out in the wild, in the real world? What it suggests is that when you're actually talking to someone, when the situation matters, the brain changes its entire strategy. Instead of relying on that quick reactive braking from moment to moment, it seems to switch to a much stronger proactive control. It puts a heavy, sustained brake on the dominant language ahead of time, all to make sure communication in that weaker second language is as smooth as possible.
And the authors themselves really drive this point home. They say that our theories about the bilingual brain can't just ignore the environment anymore. The social context, the visual world around us. It's not just background noise. It's a key ingredient in the recipe that decides which cognitive tools we use and when. And this leaves us with a really powerful final thought. This one study shows that just by moving from a sterile lab task to a richer simulation, we can completely rewrite our understanding of how the mind works. It really makes you wonder, right? What other secrets of the human brain are we missing just because we've been looking for them in the wrong places?